MCQ 19 is going to be with regards to CFC. So this is a common state knowledge. Starting off with the initiation process, which involves UV light and CFC, CCl2F2. It will undergo the process of homolytic fission to generate a chloride radical. And the original CFC will now become a C radical, Cl and F2. In the propagation step, the chloride radical will then react with ozone, which is another round of your homolytic fission, and this will get us a ClO and the presence of O2, and the radical remains with our ClO. Now the ClO then will attack an oxygen molecule, and from this attack itself, as per the second equation here, two parts of our ClO will actually cause the regeneration of two of our chloride radical and production of 2 units of oxygen. Now you can see that this is a perpetuating event because the chloride that was regenerated will actually be able to participate in another propagation step to break down ozone O3 into O2. Now, as per all form of your radical reaction, a termination step ensues when two radicals actually comes together. So it could be a chloride radical colliding with a chloride radical to get chlorine, or it could be a chloride radical colliding back with the original CFC radical, regenerating CFC. So take a look at the case here. Statement 1 is wrong because although this is being generated here itself, we have to be aware that it should have been an F2 and a regular Cl1, and the radical generated should have been a chloride radical. So second step, yes, the halogen radical here, which is the chloride radical, is acting as a catalyst because it can perpetuate back into the propagation step to be regenerated over and over again to help in the breakdown of ozone. And lastly, halogen radical is formed during termination is out because it should be formed during the initiation step in the presence of UV light. So the answer here is D, which is just option 2.